For topic two, we're going to look at graphing systems of linear inequalities. So systems, okay. We've already dealt with just solving systems of equations in two variables. Now we're going to look at solving systems of inequalities, okay. So we have a few definitions that we need to remind ourselves of. So first, we have that a system of linear inequalities in two variables consists of two or more inequalities that must be solved simultaneously. That is very similar to the definition for a system of linear equations. It's two equations that we solve simultaneously. And remember, with a system of linear equations, the solution was the point where the two lines would intersect. Okay, so how is that going to translate to this world of inequalities? Because remember, with a linear inequality in two variables, you're not dealing with just a line. You're dealing with a line, maybe the points on the line, maybe not, depending on the inequality symbol. And then you're dealing with a half plane that is shaded. Okay, so how do we talk about the solutions to systems of linear inequalities in two variables? Well, the solution to a system of linear inequalities is the set of all points x, y that satisfy each inequality in the system. So what is that? Like, what is that actually going to mean in terms of these graphs? Because we are going to have to graph these to get the solution. So graphically speaking, we want to indicate, I can't spell, let me fix that first. We want to indicate where the shading for the two inequalities overlaps. Okay, and that ends up being our solution. So we're no longer looking for just where the two lines cross, the point of intersection. Now we're looking to see where do the shaded regions intersect. So where's this overlap for the shaded regions? That ends up being our solution here. All right, so steps to solve. Luckily, we've practiced all the parts. We just have this one new idea of, hey, where does the shading overlap? So what we would do is graph each inequality on the same coordinate plane. So one Cartesian plane, two inequalities. It does get a little messy, so go above and beyond to just be as neat and precise as you can. Okay. Shade the region that satisfies each inequality, but you don't want to like fully shade. You just want to kind of like very gently shade to avoid like even more of a mess. Okay. The solution is the overlapping region where all inequalities are true. So it's where the shading overlaps. Okay. Use caution with the actual point where the lines intersect. So you've got these two inequalities, and we're mostly concerned with where does the shading overlap. However, the point where the two actual lines would intersect, we have to use caution there. Okay, so when we look at that point of intersection, if both inequalities are less than or greater than, so just strict inequalities, then we would use an open circle at that point. If both inequalities were or equals to, we would use a solid circle or like a solid dot to indicate, hey, this point where these two lines intersect is included in the solution set. However, it becomes tricky when you have one of each. So if you have both strict inequalities, then it's going to be an open circle where the two lines intersect. If you have both or equals to inequalities, then it's going to be a closed circle. The issue is, what if you have a mix of those two? Well, here's the trick. If either inequality is a strict inequality, doesn't matter if one or both of those inequalities is a strict inequality, you would use an open circle here. So the only way you could use a closed circle where the two lines actually intersect is if both of the inequality symbols were an or equals to inequality. Okay, so just be mindful of that, and then let's practice. Okay, so example two here says graph each system of inequalities. So we're going to graph these just like we did the linear inequalities in two variables in part or topic one. Okay, now luckily for part A, the inequalities that we've been given are both already solved for y. That makes it a little bit easier. So I'm going to use two different colors here. I'm going to use purple and like red, something that we can see kind of nicely. All right, so for this first inequality, we're going to go with purple, okay? So for the purple inequality, my slope, remember, as long as we are solved for y, our slope is the coefficient of x. So my slope here is 2, but I like to have a fraction as my slope, so I'm just going to write it as 2 over 1. My y-intercept is -3, okay? I do have a strict inequality here. It says y is greater than, just plain old greater than 2x minus 3. So I'm going to use a dotted line. And then remember, as long as you're solved for y, there's a hint about which half plane you're going to shade. Whatever this reads right here, take it literally. If this says y is greater than, think we're going to be shading above that line, okay? But I'll put a little star here and say we're going to shade above. We can still test a point, okay? Now for the second inequality, I'm going to look at it in red, okay? Again, it's already solved for y, so we don't have to do that work. But remember, the slope, as long as you're solved for y, the slope is the coefficient of x. So my slope is -1. But again, I want it to look like a fraction, so I'm just going to put it over 1. My y-intercept, as long as I'm solved for y, is just the constant. So my y-intercept is 6. I do have an or equals to inequality. So in this case, the actual points on the line are part of my solution set. To indicate that to the reader, I use a solid line. And then finally, we're going to get a hint about which direction we're going to shade. We'll still test a point, but this says y is less than the line -x plus 6, so we want to shade below the line, but we'll still test with a point. All right, so let's go back to purple and graph that line. Let me shrink this just a smidge so everything fits in one screen. Okay, there we go. So for the purple line, we have a y-intercept of -3. So at the origin, I don't go left or right. I just go down 3. So down 1, 2, 3. And then I need to apply my slope 2 or 3 times. So my slope is 2 over 1. So that would tell me to go up and then to the right. So from my y-intercept, I could go up 1, 2 to the right 1. I could go up 1, 2 to the right 1. I could go up 1, 2 to the right 1 again. Okay. Now remember, you can always completely reverse that process. I could go down 2 to the left 1, still on the line. Down 2 to the left 1, still on the line. Down 2 to the left 1, still on the line. So I can go down 2 to the left 1, down 2 to the left 1. However many times you want to do this, I would say do it a few times as long as your line will still fit on the Cartesian plane you're provided with. And we do want a dotted or a dashed line, so I'm going to add just a few more dashes so I can complete this line. And then we think we're going to shade above, so let's go ahead and test a point. Now, as long as your line does not go through the origin is always going to be the easiest one to test. So let's, in purple, test the origin. All right, so anywhere we see an x or a y, we're going to replace it with 0. So y, that's 0, is greater than 2 times x, which is 0, minus 3. Well, 0 is just 0. That doesn't change. And then 2 times 0 is 0, and 0 minus 3 is -3. So is 0 greater than -3? Yes, this is true. So the origin was up here above the line. Okay, we want to make sure we include the origin in our shaded region. So we do want to shade above the line. So what I'm going to do is I'm just going to put a few really gentle lines to remind myself, hey, I'm shading above this line. Okay. And then let's go to the line that we're going to graph in red. Okay, so in red, we had a y-intercept of 6. So at the origin, I do not go left or right. I do go up 6, though. So 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, yes. And then it's sort of shaded. Let me make it a little bit better. So 1, 2, 3, 4, 5, 6. All right. And then we want to apply our slope. In this case, our slope was -1 over 1, so that tells me to go down and to the right. So I'm going to go down 1 to the right 1, 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 down 1 to the right 1. I could also go up 1 to the left 1 if I wanted to. But I've got enough points here, so I think we can get a general idea of what the line's going to look like. Now, in this case, we can include the points on the actual line because we have a less than or equal to inequality. So we want to connect these points with a solid line. Okay, now we think we're going to shade below the line, but let's go ahead and test a point. So again, as long as your line does not go through the origin is always going to be the easiest point to check just because you're plugging in zeros. So let's plug in some zeros into the original inequality. That means anywhere you see an x or a y, replace them with 0. So I get 0 is less than or equal to -x, which is really 0. And then plus 6, well, 0 is less than or equal to, 0 is just 0, doesn't, the positive negative is just 0. So we get 0 plus 6, which is 6. So 0 less than or equal to 6. Is that true? That is absolutely true. All right, so remember the origin is down here. We want to make sure it's included in our shading. So technically we want to shade everything below this line right here, right? but we're really interested in where the shaded regions overlap, okay? So they overlap not over here. So those lines can go away. Not up here, that line can go away. You can kind of see the crosshatch. That's where our shaded region overlaps, okay? So we can go ahead and kind of slightly more aggressively shade that in. So I told you they're a little bit messy. All right, the only issue that we really need to address now is the point where the two lines intersect, okay? So we had in purple, we had a greater than inequality. In red, we had a less than or equal. If either of these two inequalities is a strict inequality, meaning it does not have that or equals to line, then you have to use an open circle where these two lines intersect, okay? So let me see if I can, whoops, I didn't mean to erase my whole line. There. So we want to make sure we put an open circle here where those two lines intersect, okay? So our shading is going to be like this. So all of this shading in black, and then we have an open circle where the two lines intersect. Okay, let's go to part B. All right, so for part B, we have 3x plus y is less than 6, and then we have x plus 2y is greater than or equal to 2. We need to do some work here. We want to solve both of these for y, okay? So let's do the same thing that we did before. We'll use purple and red, okay? So for the first line, let's work on it in purple. So we have 3x plus y is less than 6. I want to solve for y. All I have to do here is subtract 3x, which is nice. And that gives me y is less than negative 3x plus 6. So my slope, as long as I'm solved for y, is the coefficient of x. So my slope is negative 3 over 1. My y-intercept, as long as I'm solved for y, is 6. And then I have a strict inequality here, so we're going to go with a dotted line. And then as far as shading is concerned, we need to always test a point, but right now we have y is less than, so that lets me think I'm going to shade below. Okay, so let's go ahead and address this line. Let's just do everything in purple. So my y-intercept is 6. So at the origin, I don't go left or right. I just go up 6. So 1, 2, 3, 4, 5, 6. And then my slope is negative 3 over 1. That tells me to go down and to the right. So I can go down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1. I could also instead have gone up 1, 2, 3, but then I'd have to go to the left one. Get 4 or 5 points. I think that's always wise, especially when you're just applying the slope. It's easy. So as long as you have 4 or 5 points that'll fit in the Cartesian plane, do 4 or 5 points, okay? Just make sure you get a good idea of what your line looks like. We do want a dotted line. Pretend it's straight as can be. I don't have a ruler here, so we're just eyeballing it, okay? And anytime you eyeball it, it's gonna be a little wavy. Just squint your eyes and pretend, okay? And then we think we're gonna shade below, okay? But let's test a point. So in purple, we're gonna test 0, 0, the origin. So anywhere I see an x or a y, I replace it with a 0. So 3 times x is 0 plus y, which is 0, is less than 6. Well, 3 times 0 is 0. 0 plus 0 is still 0. Is 0 less than 6? Yes, this is absolutely true. So we would want to shade below the line. So again, I'm just going to put a few gentle lines so I can remember which direction I'm shading. Okay, let's switch over to red. Okay, now in red, we have x plus 2y is greater than or equal to 2. We're going to start by isolating the 2y, so I'm going to subtract x. X minus itself is just 0, so I'm left with 2y is greater than or equal to negative x plus 2. I need to undo the multiplication of 2 and y. We do that with division. We're dividing everything by positive 2, so we don't have to reverse an inequality symbol. 2 divided by itself is 1, so I get y is greater than or equal. Well, negative x over 2 is like negative 1/2 x, and then 2 over 2 is just 1. So this is what I'm really graphing, okay? So my slope is negative 1/2. My y-intercept is 1. We do have an or equals to inequality, so we are going to connect the points with a solid line. And then as far as where we think we're going to shade, we have y is greater than or equal. So we think we're going to shade above We will test a point in just a bit though, okay? So let's see, at the origin, I don't go left or right, I just go up 1. And then from there, my slope is -1/2. So I go down 1 to the right 2. So down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. I could also go up 1 to the left 2, up 1 to the left 2. Get several points that you know are on the line. Whoops, my display is falling apart. There we go. And then we want to connect with a solid line. And again, when I freehand, you have to really squint your eyes and pretend it is perfect. Okay? So there we have it. Now we want to figure out our shading. So our line, it's really close, but it does not go through the origin. So we can test the origin. All right, so we have 0 for x plus 2 times y, which is also 0, is greater than or equal to 2. Let's see, 0 plus 2 times 0 is just 0. And then we want to know, is 0 greater than or equal to 2? No, this is absolutely false. So since the origin is right here and we know it is not going to satisfy this second inequality, we cannot shade the region that contains the origin 0, 0. We have to shade the opposite side. So we want to shade on top of this line. Okay, so let's think about where this shading is going to overlap. Okay, so we want to see where the purple and red dashes kind of overlap each other. And I can tell you right here, they do not overlap here or here or here or here or here or here. They kind of overlap in this little tiny upper, they don't kind of, they absolutely overlap in this little upper left-hand corner that we've created. So let me clean it up a little bit. All right, we are going to end up shading right here. But we still have to address what happens where the the two lines actually intersect. Remember, the only way you can get a closed circle where the two lines intersect is if both inequalities have an or equals to. If either of the inequalities or both inequalities is a strict inequality, meaning just less than, just greater than, you have to use an open circle here. Well, we definitely have a strict inequality right here, so we need to make sure, well, let me fix that. Didn't mean to erase my whole line again. There we go. So where these two lines intersect each other, we need to make sure we have an open circle. Okay, so there you have it. That is systems of linear inequalities. They are, like I said, they're kind of messy. I would say your best bet is to have be very neat and organized, have some kind of system where you really keep track of which line is which. For me, I always use 2 different colors. So if you have some colored pencils, that can sometimes help. All right, let's look at 2 more. So this is going to be kind of a longer video. I probably could have done 3 examples. Maybe 4 was a little bit much. Okay, for part C, luckily, part C is pretty quick for us. We're not going to have to do a whole lot of work. Our first inequality is already solved for y, so we don't have to do the work to solve it for y. And then our second inequality is missing a y. Okay, so remember, when one of the 2 variables is missing, you either get a horizontal or a vertical line. Okay, let's first just deal with the first inequality. Okay, so for my first inequality, y is greater than x minus 1. I can already tell you like the slope and the y-intercept and all that. So my slope, as long as I'm solved for y, is the coefficient of x, which is just 1. So I can have a distinct rise and run. I'm going to just put that over 1. My y-intercept, as long as I'm solved for y, is the constant. So my y-intercept is -1. We do have a strict inequality here. So that tells me I'm going to use a dotted line. Okay, and then this says y is greater than x minus 1, so I think I'm going to shade above, but we'll still test a point. All right, so at the origin, I don't go left or right, but I do go down 1. That's my y-intercept. And then I want to plot my slope. The slope is just 1 over 1, so I'm going to start by going up and to the right. So up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Do that a few times. I could also go down and to the left. So down, left, down, left, down, left. Get a few points. We definitely want to connect with a dotted line. And then we think we're going to shade above, but let's test a point. Now, you know you go through the origin if you get a situation where when you solve for y, you don't have a constant. The constant is just 0. So even though this line is really close to the origin, I can assure you it does not go through the origin. So we can test 0, 0. So anywhere you see a y or an x, replace it with a 0. So I get 0 for y is greater than 0 for x minus 1. Well, is 0 greater than -1? Yes, that's absolutely true. So that verifies that we do shade above the line. So again, just a few little dashes just to keep track in your mind which direction you're shading, okay? Now in red, we're going to look at this line right here, okay? So we're missing a y. What does that mean in terms of these linear inequalities or linear equations in two variables? Well, if one of the two variables is missing, you cannot touch that particular axis. So in this case, y is missing. We cannot touch the y-axis, but we do have an x, which means we have to touch the x-axis. For that to occur in the Cartesian plane, the line would have to be vertical. Okay, so this is a vertical line that has an x-intercept of 5. So figure out where 5 is on the x-axis, and then we want to draw a vertical line. But you still have to do the solid line, dotted line, just like with the regular two-variable inequality. So we've got a strict inequality here. So this tells me I'm going to draw a dotted line. And then as far as shading goes, with a vertical line, you can't shade above or below a line because it's vertical. So you either shade to the left or to the right. Okay, so let's first figure out where our x-intercept is. So at the origin, I go to the right. 1, 2, 3, 4, 5. I want to draw a vertical dotted line. Okay. And then we have that we have that x is greater than 5. So I would want to shade to the right of that line. Okay. So where do the two shadings overlap? So let's kind of clean it up. They don't overlap here, 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 any of those. They overlap in this kind of upper right-hand corner. Okay. So my shading is going to be all of this right here. And then because we had two strict inequalities, meaning there was no or equals to component, where these two lines intersect, we want to make sure we put a nice big open circle. Okay. Now for part D, luckily the work has been done for us in terms of solving for y. We don't have to do that extra step, which is nice. So let's, I wanted to do purple first, just to be consistent. Purple. Okay, so this first inequality, we're going to do everything in purple. Okay, so for the purple inequality, we have a slope of 2. So remember, as long as you're solved for y, the coefficient of x is your slope. And I need a distinct rise and run, so I'm going to put it over 1. My y-intercept, as long as I'm solved for y, is the constant. I do not have a strict inequality here, so I do want to connect with a solid line. And then we have a hint about which direction we're going to shade. We will still test a point, but this states that y is greater than or equal, which means we would probably shade above, but we will double check with a test point in just a bit. Okay. So let's see. At the origin, I don't go left or right. I do go down 3 for my y-intercept. And then to apply my slope, since my slope is 2 over 1, I want to go up 2 to the right 1. So I'm going to go up 1, 2 to the right 1, up 1, 2 to the right 1, up 1, 2 to the right 1. Do that a few times. But also remember, you can go down, but if you go down, you have to go to the left. So I could also go down 2 to the left 1, down 2 to the left 1. Either way you slice it, still on the same line. We want to connect with a solid line. Pretend that isn't crooked. All right. And then we think we're going to shade above, but let's test a point just to be super duper certain. So as long as your line does not go through the origin, you can test the origin. Our line does not go through the origin. So let's see, anywhere you see an x or a y in that first inequality, replace it with a 0. So we have that y is greater than or equal to 2x minus 3. Well, 0 is greater than or equal to, let's see, 2 times 0 is 0, minus 3 is negative 3. So 0 is greater than or equal to negative 3. This is true. That means we want to shade the half plane that contains the origin. So again, just a couple of really gentle lines here. Okay. Now we're going to switch over to red for the second inequality. So for the second inequality, my slope is again 2 over 1. Okay. My y-intercept is 1, so 1. I would again use a solid line to connect these points. And just like before, we can have a hint about which direction we're going to shade. This inequality reads y is less than or equal to 2x. So we're going to shade below, but we'll test a point. Okay. So let's see here. For the y-intercept at the origin, I don't go left or right. I just go up 1. My slope, I can go up 1 to the right 1, or up, ooh, excuse me, up 2 to the right 1. So up 1, 2 to the right 1, up 1, 2 to the right 1, up 1, 2 to the right 1. I could also go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. Connect with a solid line, and I'll be daggum. Pretend these lines are perfectly straight, okay? Because mine are a little wobbly, okay? Now, in this case, what we wanted to do is we wanted to shade below the line. So let's test a point. It looks like this line goes through the origin, but I promise you it does not go through the origin. In order for a line to go through the origin, it would have to be of the form y equals mx with no b. B would just be a 0. So we do not have that format here. So even though it looks like this line goes through the origin, it does not. All right. So we're going to test 0, 0. So anywhere I see an x or a y, replace it with a 0. So I get 0 is less than or equal to 2 times 0 plus 1. Well, 2 times 0 plus 1 is 1. Is 0 less than 1? This is true. Okay, so we do shade below. So let's think about what this means. Where do the purple and red dashed shaded components overlap? They overlap between the two lines, okay? It turns out these two lines are actually parallel to each other. And you know this is going to be the case when you have two lines that when solved for y, they have the same slope, but they have different y-intercepts. We have the same slope, we have different y-intercepts. So these two lines have exactly the same tilt, which means they're never going to intersect, okay? So the shaded regions here end up being that little region between the two lines. So let's clean this up a little bit. Okay, we're going to shade here. Now, the two actual lines don't intersect, so we don't have to worry about an open or a closed circle at that point of intersection. So this right here is our solution. Okay, so there you have it. That is linear inequality, or that's systems of linear inequalities in two variables. And I think that's it. Yeah. So for topic 1, we looked at just solving linear inequalities in two variables. Topic 2, systems of linear inequalities in two variables. All right. So that's it. The last section, we skip a section in the book. We're going to jump over to 7.6 for the next video, and we'll talk about exponential, logarithmic, and quadratic functions.